Hey guys, today we're going to be taking a look at how we can solve this problem. So we know that from the question, f of x is continuous. And from our first hint over here, we know that if limit as x tends to a of f of x equals f of a, then f of x is continuous. In other words, if f of x is continuous, then this must be true. So let's actually apply the first hint right now. We know that limit as x tends to a should be equal to f of a. A in this case is going to be pi over 2. So we're going to have pi over 2 over here of f of x, and then we're going to have f of a or f of pi over 2. Our right side, f of pi over 2, that is just going to be 3 from our function. Now let's simplify the left side. The left side says limit as x tends to pi over 2 of f of x. We need to figure out what f of x is going to be. And f of x is going to be this function right over here. And that is because this function is only true when x is not equal to pi over 2. And that's exactly what a limit means. A limit means that you are approaching that value. You're not equal to that value, but you're approaching it. And that's exactly what this statement is saying. We're approaching the value, but we're not equal to pi over 2. And that's exactly what a limit is. So, but you're going to notice one thing. If we put in pi over 2 directly in this, we're going to get 0 over 0, and that's an indeterminate form. So in other words, we are going to apply the second hint right over here that has something to do with sign. We need to recreate this into a way that we can actually find the value of k, and we'll do so by using the second hint. So we need to figure out how to make this cos into a sine as per the second hint. So in order to do that, lucky for us, we know our trigonometric identities and how they're related to each other. So we could say limit as x tends to pi over 2, k sine pi over 2 minus x over pi minus 2x. All I did, I replaced cos x for sine pi over 2 minus x. They're the exact same thing. And now over here we have a sine pi over 2 minus x. I want to get a pi over 2 minus x in the denominator as well, because we see in the second hint we have an x at the top and an x at the bottom. X is just a function. In our case, that function is just pi over 2 minus x, and I want to get that in the denominator as well. So here's what I'm going to do. I'm going to write limit x tends to pi over 2, k sine pi over 2. And I'm just going to put pi over 2 at the bottom, right over here. Now, obviously, this isn't equal to this over here, but if I multiply the denominator by 2, we see that if you expand this, you get the original denominator. And now we can say that this is just equal to 1, as said over here, that is 1. All you're left with limit as x approaches pi over 2, k over 2, that is just k over 2. We already established that's equal to 3, and hence k is equal to 6.